if y square is less than equal to 25 minus x square and 4x plus 3y is less than equal to minus 12, what is the maximum possible value of y? This is a problem on inequalities, which is a common topic in all standardized tests, and it may appear hard to some, but these problems are best done with graphical representation, taking help from coordinate geometry, which may make them easier to understand and also make it easier to figure out how to go about solving these problems. So I start with basically writing down the first inequality, which is y squared is less than equal to 25 minus x squared, and if I bring x over to the other side, I get x squared plus y squared less than equal to 25. Now if I write this inequality as an equation, I get this, and this is a very well-known equation when you're thinking in terms of coordinate geometry in xy plane, because this represents a circle whose center is at the origin and the radius of the circle is basically 5. So x squared plus y squared equal to r squared. That's very well known to be the equation of a circle with center at origin and radius r. In this case, r is 5, so that's why you have 5 squared 25 on the right hand side. So let's draw out this circle in the xy plane. So this is the xy plane, and that will be my circle, center at origin, and this circle will basically intersect the x-axis at 5, 0 and minus 5, 0 on the positive and negative sides of the x-axis respectively, and similarly on the y-axis the points will be 0, 5 and 0, minus 5. So I've shaded this circle basically showing that my inequality requires that the point lies inside the circle. So if y squared is less than equal to 25 minus x squared, then those points which satisfy this inequality on the xy plane would have to be inside the circle. And why is this? Well, if you consider a point P on the xy plane and let the coordinates of P be x and y, then distance of the point P from the origin is basically square root of x squared plus y squared. So if I take a square root of our given inequality, that means that root over x squared plus y squared is less than equal to 5, right? So essentially what this means is you have the points, you have those points that satisfy this inequality, their distance from origin will have to be less than 5, less than or equal to 5, but they can't be more than 5. Now if I consider any point within the circle, the distance of that point from the origin has to be less than or equal to 5, because it can't exceed the radius of the circle, right? But if I consider points outside the circle, then clearly x squared plus y squared would have to be greater than 25, because those points, the distance of those points from the origin will have to exceed the radius of the circle. So that's why this inequality means that my points, the points that are satisfying that this particular inequality would have to lie inside the circle. So what about the other inequality? Well, that's a simple one. It's a straight line. So if we write that inequality as an equation, that will be a straight line in the xy plane. And we can find the intercepts of that line on the x-axis and the y-axis by plugging in y equal to 0, we have x equal to minus 3. We can also plug in x equal to 0, get y equal to minus 4. So let's draw out those points on the x and y axis respectively, and then if we just join them, this is the line. Now, for the inequality 4x plus 3y to be less than equal to minus 12, that means that the points which will satisfy this inequality will have to be below this line on the xy plane. So now if you think about the set of points which satisfy both the inequalities, that means that those points will have to be lying below this line, and they would also have to lie inside the circle. So clearly this striped area, right? So that's the common area, right? Which will satisfy both the inequalities. Now that we know which set of points on the xy plane will satisfy both the inequalities, it's easy to see from here what the maximum value of y will be. So this will be the maximum value of y, right? Now, how do we solve for this? So for that, we have to treat these two as equations, right? And just go about solving them. Just treat them like regular equations and find x and y, and then we can find the common points of the circle and that straight line. So just substitute or express x in terms of y from the linear equation, and we're doing this because here we're interested in solving for y actually. So once we have expressed x in terms of y, we just substitute that in the equation x squared plus y squared equal to 25. So when we do that, this is what we get. Then we expand out the first term, and from here on we multiply both sides by 16 just to get rid of the fractions. And then if we do a little bit of math and algebraic manipulation, we finally come up with this quadratic equation. And the roots of this equation will be basically applying the formula minus b plus minus root over b squared minus 4ac by 2a. So that's the standard formula for roots of a quadratic equation. This is what we get. And then further calculating the value within the square root, we are left with this one. Now we have two values of y. One is clearly more negative than the other, right? And that's probably that lower point where the line intersects the circle. So we aren't interested in that point because the upper value of y is the maximum value, right? So we're interested in that upper value of y, which at least from the graph, it appears it's a positive value. So we ignore the root, which is obviously negative, and take the other one, which would give us the maximum value of y. And if you calculate this out, I calculated this using a calculator. This is the value that it came to, 2.069. So the maximum value of y in this case would be approximately 2.069.